You can join me in the LinkedIn and the Twitter. So who we are a design and engineering studio with user-first and AI approach. We are a community-driven company focusing on tech stacks like React, React Native, and Flutter. We have built some amazing products. You might have heard about GlueStack. So GlueStack, it's a universal UI library. It can be used for any industry, and if you are interested, do check it out. Among all of these things, we are an active part of tech and business community. We host a lot of meetups such as this one, and we have a plan to host, as in planning, you can say that 3 meetups in 2 months. So everything is, the visibility is there in the meetup.com. You all can go and register. And whenever we conduct the meeting, it is visible over there what are the dates. Sometimes we do in our venue, sometimes we do other venues as well. So we collaborate with some other community and we do that. And here itself, we have, last year, this is the images for the conferences, which we did last year in the React Native EU. It was in Poland. And we did a meetup as well. This is the conference and meetup both. Meetup we did in London, that is React Advanced London. It's a name, it is, of course, it's there in the meetup. You can have a look of it. And let's have a code of conduct. This is just a normal thing wherein you have to just maintain silence over there. Whenever the speaker will come, just scream as much as possible, because this is required just to motivate them whenever they come on the stage and whenever they leave. So the sound is required from your side. And this one, about any questions you have. So the speakers will be there. They will finish up as a flow. If you'll say 2 speakers, then there'll be a break session. Then 3 speakers, then you'll be having a snacks time. And over there, if you're having any questions also, you're always welcome to put in the LinkedIn, or there'll be a networking session on the break time, and at the end during snacks, you can have a networking session as well. Yeah, so this is the Wi-Fi here. You can scan and you can use your net over here. GeekyAnts @guest 2023. You can scan and you can utilize that. I would request the back guy, you can just have a seat in the front. It'd be much better for you. Just come down here yourself. The chairs are empty. Yeah. Great. Thank you. So let's kick off and we'll start the session here. This is our GeekyAnts handle for the Twitter and LinkedIn. And yes, we'll start now. Second. So to tell you about more, we are going to have the DevOps community here, and I would like to introduce you our keynote speaker of the day. His name is Faiz. He is ADOA at GeekyAnts, and let's welcome him. Please welcome him, please. With a big noise, yeah. Just a minute. It's on.
Hello. Thank you, Prem.
Yeah. Just.
Hello, everyone. Am I audible? Like. Okay, let's start this. So our theme of this DevOps meetup is automation and monitoring in DevOps. So previously we did lots of stuff around hypervisors and micro VMs. This we are focusing on automation and monitoring. So how do we do it in DevOps? We will be discussing all this stuff here, and we have this is me, and you can follow me. You can check my profile on GitHub and LinkedIn. So let's talk about automation. What is automation? So in automation, when it comes to what is the general thing that you guys can understand, like come up with when we say automation? Anyone, just a specific answer out of like these things. When I say speed, what does this speed denotes in automation? Anyone? Exactly. Execution time, agility, right? So for automation, the speed is basically we want to go to market as soon as possible. Right? And with automation, you will remove the human intervention, right? And since it is an automated process, obviously your deployment time and will be consistent, and you it would be a constant value, not like you could give out like plus minus 2 to 3 second of differences. But yeah, that's automation. Consistency is like, let's say if you have developed something, if you have written a specific code for it, it will obviously do that specific job. So you know that there is a consistency in the deployment pipeline, right? If you're doing something and you have defined like your code to do it in a specific way, that is consistency. So automation allows us with that consistency. Then reliability. I know if something goes wrong, I know if like something goes like bad about my pipeline or my automation like stuff, it would obviously report me, right? So I know it is reliable for me whenever something happens. Let's say if somebody pushes or if somebody make a change and you have an automation in line, it will obviously I can rely on it to like work on that specific changes and do the job it has defined, right? So for me, automation is speed, consistency, and reliability, right? Let's move to other slide. Monitoring. So monitoring is proactive issue detection, enhance visibility, and improve reliability, right? When I say proactive issue detection, if you have a monitoring tool, right? Monitoring tool is supposed to work on issues, right? If there is anything which you might not know, like let's say the bandwidth of a specific link is down, or it has reduced its speed, or anything like that is happening, right? So you cannot identify using like you cannot physically go to 10,000 of servers and see what device is having what issue on what interface. So I would say monitoring helps me to proactively find those kind of stuff, right? There are lots of other issues like in terms of hardware or a software or network level. So all these issues can be monitored, right, using automation. So, and yeah, then come to let's come to enhanced visibility. What is enhanced visibility? As I said, like you cannot find out everything going bad about your servers or your networks or your softwares, right? Using a visualization tool and using a like proper monitoring tool, you can identify what went wrong and what's happening, what is really going to happen with some kind of changes which is now affecting your infra. Then improve reliability. Obviously, if there is some tool which will help you to identify such things, right, you can rely on it, even if it is like let's say 12 o'clock in the midnight, right? You don't have to like specifically keep monitoring everything. It will automatically give you a notification or stuff like this. So for me, this is what automation and monitoring should do, and this is what we are here to talk about. Let's talk about the synergy between these two. Automation ensures that development is good. Monitoring keeps providing you the feedback depending upon what's really happening for your infra, right? So this is what I've defined for automation and monitoring, and what is the synergy between these two. What are we doing at GeekyAnts right now? Like since 6 to 8 months, we are preparing our own data center. We have our all services, which is right now provided by Azure as well as Amazon, right? We are using OpenStack and different stuff to cl- create our infrastructure. But these are all the tools that we are right now using in GeekyAnts for our customers as well as for our internal projects. We have Zabbix. Zabbix, as you all might know, it is like a monitoring tool which will help you in monitoring your infrastructure, like network, hardware, or software. Then comes the Ansible, which will help you in automation. Right, you can write lots of automation scripts using Ansible. Same goes for Nagios. Like if you have a specific choice to go only with Amazon or Azure, you can use their services like Azure Monitor and CloudWatch. Then there is Sentry for your APM, application performance monitoring. Right, it is specifically designed to work with your applications. So and Sentry provides you lots of integrations with different kinds of technologies and frameworks. Like if you are using PHP but you want to use Laravel or a Magento, then you can use Sentry, and it has a specific configuration for you. You don't have to like write lots of code. You just need to configure a few things in terms of like Magento or Laravel. Same goes for front-end applications like Astro, Next.js, or React. So yeah, Sentry is what we are right now using for lots of our applications. We have our own self-hosted Sentry as well as Zabbix right now at GeekyAnts. Now let's see who we have. We are gonna like see here on stage today. We have Aditya Prakash, senior DevOps engineer at level 2 at GeekyAnts. Then we have Vasuki Vardhan, tech lead 1 at GeekyAnts. Then we have Vijay Rangan, who is founder and CTO of Vijay Rangan Consulting. And then we have Pavan Tikkani, founder of Prag-Matic. Then at the end we have Ayushman and Girish. They will be pairing up to showcase how infrastructure monitoring is done using Zabbix. So yeah, this is all we have right now. And as Prem has said, like we will have two speakers come up here, then we will have a break, and then the other three speakers, then we will be like gathering around and we will talk about stuff that we can discuss from this talk today. All right, let's get started. Thank you, everyone. Let Prem, you can come on board. Thank you, everyone.
Thank you, Faiz. Thank you so much for this session. It's really very valuable. So now we will be moving our session with the first speaker now, and he is a tech lead at GeekyAnts, and he is a tech enthusiast who likes to work in and around platforms, backend and AI. Today he is going to dive into the ethics of AI in DevOps. Let's hear more from him, and yeah, please welcome him.
So good afternoon, everyone. I'm Vasuki Vardhan. So I work as a tech lead here at GeekyAnts. Right. So today I'm going to talk about a bit of ethics that we usually encounter and or even think about while using AI in DevOps. Right. So in from past few months, we are already riding the generative AI wave, right? So a lot of things have been happening. We are seeing multimodal models coming to a very huge play, and a lot of things have just burst open through a bubble, right? So you're trying to figure out a lot of productive ways to use AI, and also a lot of creative ways as well, right? So one of the key areas that even we were thinking about in GeekyAnts and also using is using the power of AI in our DevOps process, right? So that can be our traditional old GitOps, DevOps, or even today's MLOps processes, right? So we are mostly looking into the kind of biases required or debiasing required uh, while using AI in DevOps, who are all accountable for all the moving components in the entire pipeline, and also the amount of transparency and all the areas of transparency that we think that needs to be available to implement DevOps in any kind of platforms, right? So basically, taking the first part out is transparency, right? So when you're dealing with a lot of these enterprise infrastructures, so and every single component is crucial, right? So every decision that the AI model is taking should be explainable, right? So you should be able to explain why this decision was made or why the AI is able to take this decision low. So let's say a very basic example is when you are creating a deployment and let's say you're implementing AI to uh, predict and apply a set of migrations onto your database, right? So let's say that is a small use case that you're looking into, right? So if the seeding has happened or the migration has happened or not is something that needs to be explainable, or how it happened, right? And a lot of these models are mostly black boxes, as we've seen. Like let's take up Gemini, ChatGPT, or Gemma, or any other open source models as well. Until and unless you have the ability to go deep into the code and understand those things, even for the open source models, most of these models are black boxes. It is a pretty complicated set of nodes that you need to understand. So for most of our DevOps engineers, this is mostly a black box, right? So you give a feature input and some output decision is being made. So probably you'll need to look at some kind of simplifications or explainable pointers using Lime and Chab model, so that you create a bit of transparency to those black boxes and understand how those models are working, right? And also the feature importance, right? So let's say you're running a set of features through the pipeline, right, which needs to get deployed or modified, or any of those pointers, or even or your own feature onto an AI system, right? So let's say you're building an AI model and you're deploying it. So the main work of the AI model is to go ahead and deploy a few microservices, right? So let's say it is doing a set of command executions with SSH, a remote SSH is just logging into your servers and running a few set of commands, right? So let's say that is one of the particular feature that you're implementing, that AI would execute or take decisions while execution, right? So also need to make sure and properly lay out the importance of that feature, right? So that everyone who is actually consuming your model knows why this feature is there. And this applies for application developers as well, when you're giving your AI supported applications to get deployed in regular DevOps models, traditional DevOps models, or even the DevOps models, right? So you'll need to specifically have to declare the feature importance. So if you're in your traditional DevOps system, let's say you are going and deploying a few decision making models into your application, which is using a lot of your critical data, right? So you'll also need to specify upfront to the DevOps teams, okay, this is the importance of this AI feature. So, and these are all the dependent data, all of these things, right? So that even they are aware of it. And also the same ways, otherwise, if they are using AI, then they will be very transparent with the AI application development team, saying that, okay, this is a feature that we have. All of your SSH commands that goes into the server, and the way that your application is booted up is actually an AI model which is taking care of everything, right? So that particular thing is more clearer, right? And the third part is algorithmic bias, right? So let's take up a few things in terms of the very basic example that I can give you is share market kind of AI models, right? So which you are deploying, that needs to have some kind of algorithmic bias, right? So your models needs to be fair with all the deployments going forward, right? Let's say you are having a bit of a dip or a spike in the market, and the data that you are using to train this model for your usage, let's say, has a list of uh, history that you have given, and there is a clear set of biases that you see, right? So probably the market has favored a certain sector of industries and not in favor of a certain sector of industries, right? So the model that you would be building and deploying will also carry on or inherit that biasing. Your model will still go ahead and keep the same biasing up and alive, and not prioritizing or giving a fair shot to the certain set of industries that was deprioritized before, and it will always prioritize the industries that were given a positive bias, right? So you'll need to create an algorithmic plan or a set of, or create a fairness of aware data augmentation, so that the data that you are feeding into your AI model is mostly bias free, right? None of the data is 100% bias free. That is always there because the data augmentation is done by a set of humans, right? So data data biasing will always be there, but the point over there is to make sure that we don't have a lot of bias into any of those data sets, right? And the same goes with the AI models as well. So let's say you are deploying a certain set of front end applications and a back end set of applications, right? So historically, if your DevOps pipelines have been prioritizing backend stability over front end stability, the AI model that you will be building now with that data will also go ahead and prioritize backend stability more over front end stability, right? Because the data suggests that this is the bias that is provided. So you need to make sure that you provide almost equal bias onto both front end and back end so that applications are deployed in a more fair manner and stability is mostly same across the table, right? So the next thing is detecting biases and how to mitigate it, right? So first thing is auditing, right? Every single data that is being used to train the DevOps AI model or even your regular AI model needs to be properly audited by multiple sources so that you have a certain set of fair data and you reduce bias by doing multiple pass of auditings, right? So that will help you a lot in terms of creating transparency as well, and it will also mitigate the biases that the model would create, right? And then standardization of metrics. So all the metrics that you are using, so probably in terms of, let's take the share market model itself, right? So it also takes through the demographic parity, all the equal opportunity scoring and everything into consideration, and you need to standardize it. So what exactly are we looking at? So all the metrics that you are using to monitor your AI model, or even the metrics that you're using to train your AI model, should be more or less standardized, right? So this goes the same for application AI and also our infrastructure AI that we'll be building, right? And also creating a diverse set of teams that is reviewing and going through your AI models, right? So let's take the front end back end biasing itself, right? So it's not just the infra team or the backend team who is more looking into how this deployment is happening and how your platform is being more stable, right? So your front end team will also be having their own set of point of view saying that, okay, this is probably not the right way of doing it. This will hamper front end's performance or a few other parameters over there. And there will be a certain set of parameters that the AI has used during training, which has led to a certain blind spots in backend. Right, so few, let's say, port monitoring or something has gone through, which is letting probably a security issue or a stability issue, something like this. Right, so you diversify the teams that have been involved into your AI development so that you reduce the blind spots, right? So you don't have a lot of surprises going forward and figure out, okay, we hadn't seen this coming, right? So if you involve a larger community reviewing your model, diverse set of people, all those perspective will make a lot of difference in addressing those blind spots and also mitigating the biases that might have been fed into during training, right? And coming to accountability, every single AI model that is being shipped out or AI based applications that have been shipped out needs a set of governance policies by default, right? At any given point of time, at least for now, human oversight or human interventions will be required, and the current, even the generative AI, larger LLMs are not mostly bug free, right? So AI will hallucinate, AI will take some missteps, or AI may take some surprising steps, might be good or bad, right? So your human oversight is always required, right? So mostly the DevOps pipeline, let's say every DevOps pipeline is now looked after by an AI model. That doesn't mean that it has reduced the requirement of DevOps engineers. It's just that the DevOps engineers who are writing the code, managing those pipelines, are more gone into monitoring mode. Every deployment that is going through is being looked after by them. Let's say if AI is going haywire and doing something, or it is touching, since it has a lot of touch points, right? It also has access to your server. It also has access to your database and everything. Let's say it is going haywire, you need a DevOps engineer to come in, cut the pipeline, take it back up, and rectify a few things so that it becomes a learning back to the AI model, right? So human oversight is always required, and while doing that, you will also create an audit trail. So you always record all the steps, all the decisions taken by the DevOps model during the entire deployment process, right? So that you get more clarity on what are all what are the decisions being made and what were the parameters for the decisions being made. And as I said before, your all the training data that is being fed into the AI model during the training phase needs to be audited, right? So that you are not leaking out any PIA information or giving out any biases during the data, right? And audit trailing during training of the AI models is more in general, both for the AI in DevOps and AI in applications, right? So let's say you are creating an AI model for restaurants, right? So all the data that is being fed as a part of training, you need to audit it so that phone numbers of real customers or names of real customers or a set of allergic information linking to a particular customer is not being fed through, right? So you'll need to keep a track of all the things that are being happening, and it's also mostly a shared responsibility. An AI model that is being run either on DevOps pipelines or in application is shared responsibility. It is like not like a single person is responsible for um, the AI's entire performance, right? So it's mostly an entire team that is coming through who are collaborating, governing the AI models performance training, and also creating a more transparent environment so that people who are looking at from a very different set is also getting clear idea of what exactly is happening, right? So it's more of a collaborative responsibility of the entire team rather than a single point responsibility, right? So as the AI evolves, so we had neural nets, we had your simple machine learning models, classifier models, to today's entire LLMs. We're having generative models and everywhere. The landscape of AI and usage of AI has evolved drastically over the last year, right? So you'll need to stay informed about all the best practices and also keep an eye on all the frameworks that are coming out. So this might be coming out from OpenAI, Google, or whoever is uh, doing a set of frameworks, right? Who have worked on AI much longer than we have done. So, and also keep track of all the partnerships that are happening, how it might affect you, and also keep a track of the AI's general annual reports that are being sent over, right? So that you'll have a better idea of what exactly is happening and exactly you can take it over. And industry perspectives, you will also need to keep an eye on what exactly you are looking at, because DevOps in AI is mostly not exactly for one particular industry. You're looking at multiple industries, right? Healthcare, critical systems, or whatever the scenario might be. You'll need to have that perspective so that your AI model is more tuned towards that. And interdisciplinary collaboration, as we spoke before, while building any application based AI model or infrastructure DevOps based AI model, it's always a good idea to have the DevOps team, have the AI ML experts, and also have the ethicists in a single room, have regular discussions with them, have regular brainstorming, and get to a point where you have good workflows which always prioritize transparency and accountability so that you have a better experience altogether, right? So over here we are not prioritizing anti-biasing a lot, because every team will put in their entire bias in terms of we telling, okay, this is a fair enough data, it will contain some amount of bias. So prioritizing anti-biasing is not, should not be an entire part of your process, but prioritizing transparency on those details is much more important, so that other people who are coming in later will have a much better idea on what exactly is happening, or why an AI took this but a particular decision, right? So as I said, like this is sorry, taking a case study. As you said initially, I took a share market model. You can also take the same for an AI approval model. So data collection is key. The historical data for based on credit score, a lot of biases will be available in those details. A lot of discrimination between the high risk takers, low risk takers, everything will be there, right? So you will need to figure out how you can debias that data set, right? And model training is also an active part. So taking that fair data and you train a model which is more fairness aware, and also mitigate bias during this development. And also, as was initially mentioned, continuous monitoring is always required. And also, sorry for a bit of havoc in the PPT. I've not seen that. And also the way forward would be, as I said, collaboration. Always maintain collaboration with all of your surrounding team, so that you have much more information and you are well informed about all the things that are happening. Continuous learning, AI is changing rapidly across multiple industries, like just from GPT 3.5 to GPT 4, or the Gemini's initial BART to today's Gemini 1.5 Flash and Pro. The change and the way at the pace things are changing and the way that AI is evolving is incredible, to be honest. So you being at your peak pace in learning makes a lot of difference, right? And also, when you're running your AI model, be more vigilant, be more aware of what exactly is being happening, and also keep an human oversight so that nothing is going haywire. And also, with AI and the blasting open of a lot of possibilities, innovation is the key. Keep innovating, keep experimenting on a lot of things. Might not be very feasible at starting. Probably it might turn into a much better system going forward. But yeah, experimenting, innovating, and keeping the ethics at a very high standard during that experimentation will basically create a much better environment when you're going into actual application development and production environments, right? So yeah, that would be it from my side. Thank you.
Thank you, Vasuki. Thank you so much.
Thank you.
Thank you for providing the practical session for this building AI. Yeah. Can we have the huge round of applause for him, please, once again? And yes, many have joined a bit late, but yes, thank you so much for coming on Saturday and spending your time here. It's really very valuable. Thanks. Thank you so much again. So we'll be moving to the next speaker now, and his name is Vijay Rangan. He is a founder and the CTO of his software consultancy. The name is Vijay Rangan Consulting, and he has over 10 years of experience and specializes in technical strategy, system design, and building stellar engineering. He will be taking about leveraging observability for better DevOps. Let's put your hands together for him, please.
All right, good afternoon, everyone. I'm, like Prem said, very wonderful introduction. I'm Vijay. Today, I would like to present about how we can leverage observability for better DevOps, but specifically how we can use OpenTelemetry while we do that. Quick introduction about who I am before I proceed. I've been in the industry for close to 11 years, so let's say greater than 10. I run my own software consulting company. I used to work at one of these companies. You may have heard of them, ThoughtWorks, Nubank, and Postman. The vision of my company is to leverage all of this expertise and then democratize that to startups around the world, building large-scale software systems and teams. The agenda for this talk, what we'll go over very quickly, just to give you a lay of the land, is what is observability and why it is useful. Some of the pillars of observability, the what and why of OpenTelemetry or OTel. You'll notice that I used a little shorthand there called O11Y, much like Kubernetes. It's observability. We look at OTel architecture, kind of a generic architecture. You can go in on this subject quite deeply if you really want to, but I will be providing a high-level overview. Leading into that will be the architecture of the demo itself, and I'll try to do a hands-on demo here itself for you. Finally, given that we are in like a DevOps-themed talk today, I will show you, or rather present a couple of cases of why observability can really help DevOps. Finally, we'll have some time for Q&A if you have any. Cool. So just a quick show of hands so I have an idea of where the room is. Have you all heard of observability? Awesome. So that's almost everybody. So observability, kind of more formally defined, is the ability to understand the state of a system by looking at its outputs. And the outputs in the parlance of observability are logs, metrics, and traces. So these signals or these outputs can come from application services like APIs, or they can come from infrastructure like Kubernetes, VMs, or they can also come out from databases and caches. So it's kind of a comprehensive look of the system itself. So you may be wondering, or since you already heard of the term observability, why it is important. So I want to take you back for a second to about 15 years ago, perhaps, I'm roughly. And we'll think about monolithic architectures. And if you were pinged at the middle of the night at that point, in a monolithic architecture, you could just tail a log file, for example, and then kind of quickly figure out what was happening in your system. Moving forward to when microservices gained a huge traction, you can imagine when you have 10, 15, actually essentially more than 5 microservices, figuring out what happened is like looking for a needle in a haystack. Like you can't actually know what happened. So as kind of an opposite of monitoring, Faiz touched on this a little bit before, is monitoring kind of just tells you that something happened, whereas observability tells you what happened and perhaps where it happened. So this kind of just allows you to go through this cycle once you have observability in place, is to go through a detection phase. Perhaps somebody, at the most basic level, your customer is going to call you up and raise a ticket saying something's gone wrong. But hopefully, if you apply observability, then you'll be able to detect it through automation. Using all of the signals that come out of it, you should be able to investigate it, know exactly what happened, where it happened, and finally provide remediation. You provide a patch, and you push that patch out to production. So at a high level, organizations get a comprehensive view of the entire system if observability is done well. And we'll look at how you can implement it in just a second. This may seem a little meta at this point. So observability really defines 3 pillars amongst which it is measured or tracked. And they're metrics, logs, and traces. Metrics are quantitative points of data. So you can think of CPU usage, RAM usage, disk usage, network usage. And the reason, of course, is it's useful is because it again provides a high-level view. You can see that on the graph there, is that you have this Prometheus dashboard, if you've heard of Prometheus, where you have the state of the system, your CPUs and RAM and all that, and gives you a good high-level perspective of what's happening. Logs, I think every developer, like 101 is logs. They are They are points of data, they're events, they're usually structured, and they usually have timestamps. There are things that allow you to debug the system more easily when the time comes. Traces, if you've not heard, and this specifically is distributed tracing. Traces are a way, in my mind at least, they're more user-facing. They allow you to like capture the flow of a request through your entire system. So let's take a fintech kind of example, like for a moment. If you imagine that the user presses a button to make a transaction, that request goes off to potentially more than a handful of microservices, event-based systems, databases, caches, etc. So traces allow you to actually visualize that request all the way through until it comes back to the user. You may be wondering why traces are more, or why they even exist if we have logs. Well, you may be right in thinking so. Logs are a form of tracing, but they're more manual. But on top of logging, tracing and tracing libraries allow you to add context to what's happening. So if you were to think about it, let's say you made a request to a database. While a log may say, made request to database, got response from database, a trace would actually show you the latency that it took for actually making that round trip, and a bunch of other meta properties that you can add to a trace, which we'll look at in the demo. So with those kind of three pillars in mind, what is OpenTelemetry? Because we've had observability for a very long time. It's not a novel concept, but OpenTelemetry is. So OpenTelemetry is a CNCF project, Cloud Native Compute Foundation project. It's not like an infrastructure component. It is a specification. And it specifies and standardizes the generation, collection, and export of those three telemetry signals that we saw, which is metrics, logs, and traces. So in order for it, like for us to implement this specification, they actually expose, much like how all of us do in our APIs, they provide APIs. They have SDKs around those APIs, and they provide a bunch of tools that help with stuff like infrastructure collection of those signals. So I don't know how clear this is, but you can see OpenTelemetry right up there. I'll zoom in on this in just a second, but this graph shows along the x-axis, it shows the commits for the project, and along the y-axis shows a summation of PRs and issues. Kind of showing you this to show you that it's a serious project that's actually being adopted by fairly large tech companies. You can also see on the right-hand side, just for quick reference, the kind of ranking it has by different matrices. All right, so all of this is fair and good, like it's, yeah, but why do we need it? We have Prometheus, we have Jaeger, we have X-Ray, we have a whole bunch of things that already do this, so why do we need a standardization layer? The problem kind of comes in because with too much choice, I think comes a lot of pain. If you just had one way of doing things, the whole world would be happy in a sense. But if you're spoiled for choice, then we also have more processes in place, more training and setup costs, and there's also vendor lock-in. So OpenTelemetry allows us to consolidate all of these things into a unified interface, much like how UPI did for payments. So if there's just too many ways of doing the same thing, and I mentioned there's vendor lock-in. So for example, let's say your dev team has implemented Prometheus for metrics, Jaeger for tracing, and any number of FluentD for logging, let's say. But the cost for this is too much. Your organization says we need to minimize cost, which is the case with most of us nowadays. We need to come up with a way to reduce this. So let's, imagine you had like 10 different or 15 different microservices, all kind of implementing these different protocols. It's going to be hard for you to go in there, change the tooling to instrument the application, collect those metrics and push those out into Prometheus. So that's a very hard step to do. So the way OpenTelemetry addresses this again through standardization is by doing three things. And we'll look at the architecture here. So the way it does it, first of all, is through SDKs and APIs. So you'll see on the left-hand side of this diagram here that you have something called auto instrumentation. And instrumentation, like hand waving this thing, is just by saying, you have something to measure, we're going to put an instrument on it so we can measure it. Like how you have a speedometer for an engine, you have instrumentation for your Kubernetes pods, application, it may be anything. OTel API and SDKs are kind of just things that implement that instrumentation. So also on the left-hand side, you will see there's instrumentation for shared infrastructure. So this can be, like it says, proxies, Kubernetes, VM, it can be anything. On the right-hand side, is your telemetry backend. And by this, I don't mean API backends. I mean telemetry backends like Jaeger, like AWS X-Ray, CloudWatch, Prometheus. These are all your telemetry backends. And in the middle is kind of this workhorse component. And this is actually something that is a deployable component in OpenTelemetry. This is a thing that you actually can write Helm charts for or manually put out a Docker image for. And this takes everything from the left-hand side, combines it, and puts it into the right-hand side. We'll look at this in the demo of how it is. It's basically a YAML file that you can configure, and it's super declarative. It's very nice. So on to the demo. So putting all of that stuff into context. For the purposes of our demo, I've spun up three services. They don't actually do much, but there is called the product service, the user service, and the auth service, your typical microservice architecture. In the middle is the hotel collector. I'll show you the configuration for that, which has been configured to push everything to a local running Prometheus. Grafana has a few offerings. So Grafana Loki for logs and Grafana Tempo for tracing. So I'll quickly bring up my screen here. Can you all see this well, or should I increase the size? Increase? Okay. Oops. Better? Well, I think the specifics of this code is not too important, but I think we all like writing code. So I will show it here. There's also actually another window here that I need. Okay. This is a typical kind of Node.js application. You have the user service, the product service, and the auth service. They're not really doing anything too fancy. A couple of things to note here, though. I'm going to like zoom into the product service, and all of the other services follow a similar pattern. So I'll just focus on this one for the sake of this presentation. There's this little library that I wrote to consolidate the implementation. This just goes too deep into the weeds for me to show you, but this is essentially an abstraction to make working with telemetry with JavaScript very easy. And so you can see here that I'm giving it a service name to kind of identify what the resource that I'm actually tracking. I mentioned the collector component earlier. So the collector component, like I said, is a deployable artifact, and it actually exposes some ports. So it's available for me because I'm running it locally. It's available on localhost, and that's the port. I won't go into the documentation again. This is all very well documented at OpenTelemetry.io. And a few other things, there's some instrumentation, right? If you remember, we briefly touched upon the auto instrumentation stuff. So this is what it looks like when you manifest it in code, is that there are open source libraries that actually do this auto instrumentation for you. Fastify, for example, auto instruments everything HTTP. So it takes a look at your middleware and all of the stuff that goes into Fastify specific stuff. It actually takes care of that for you. We will look at, just to show you contrast to auto instrumentation for this, you see here that the user service is actually using MongoDB, and you can actually auto instrument MongoDB itself. And we'll see why this is useful in just a second, but the fact that everything's doable with just a couple of lines of code is actually quite magical. That out of the way, I'm very excited to show you the collector configuration itself. So the collector at a very high level has three components. It's got receivers, processors, and exporters. And kind of go back a second to that slide that I showed you. On the left-hand side, you have things that are receiving, coming in. On the right-hand side, you have things that are going out. And the collector kind of sits in between. And that's what's happening here. So the receiver is the left-hand side of that equation. It takes all of the inputs from in different formats. So if you look at the receivers here, I have set it up so that it takes, well, this is the network protocol, gRPC. It's not using HTTP, but it's using the OTLP wire format. And then the OpenTelemetry specification, because it's a standardization, comes up with a wire format for OpenTelemetry itself. Like this, you can see below that I've actually commented it out, but it also takes a file log. So for example, if you're running a bunch of apps and you're logging everything to a local file system, it can actually read that. You can have an agent on the VM. It can read stuff from that file log and push it into the collector if you'd like. It also takes a bunch of other things. Going back to standardization, say your team already implemented Prometheus. If you want to move slowly to OpenTelemetry, as you can imagine, moving infrastructure, observability infrastructure, in a lift and shift kind of method is not possible. So say you have Prometheus kind of pushing out metrics, you can have a Prometheus receiver here and just have the collector then start collecting those records and then pushing them out as a first step. But you have a whole bunch of receivers here. Processors are a thing that happen within the collector itself. So this is stuff where you can add metadata to the collector. You can add some kind of timing function. So you can say, I want to like buffer up certain bytes of data before I push it on to my backend, because you don't want to overwhelm the backend. You can imagine every backend also has its own rate limits, and perhaps comes with it some network traffic. If you're in AWS, you know the huge cost of network egress in AWS. And also comes with it, so the rate limit itself. So you can buffer those things. And if you want to add metadata to the final record that ends up in your telemetry backend, you can do that here. Again, I will point you to the documentation for the specifics. And then finally, we have exporters, I think, which is like the really exciting part of this, is the right-hand side of that equation. Is here you can see that I'm pushing all metrics to Prometheus. I'm pushing all traces to actually speaking OTLP HTTP, which is the protocol Tempo speaks, and localhost. But you will see that here I've referenced Tempo's coordinates. But how does this all come together? Like, just giving these key value pairs is not magical. You just have to put them together, and that's where this service pipeline comes in. So you're going to say, for all of my logs, take it in through the OTLP receiver, process it with these processes, and then push it out to Loki. Similarly, for traces, take it into OTLP, push it out to OTLP. Similar with Prometheus. So what does that look like once we have done all of this stuff? So before the talk, I actually went ahead and accumulated some metrics, so we don't have to wait here and twiddle our thumbs while all of this stuff comes in. But quickly, I will give you an overview of what's happening. The first three tabs on top are the services: the product service, the user service, and the auth service. The one here is the logs from the collector itself. So you will see here, I put a debug kind of within the collector. So you can see as kind of things get buffered into the collector itself, they're being recorded here. I have some sort of script running so that we can have requests going on in the background, and I don't have to do them manually. So with all of that out of the way, I'd like to show you the output of all of this not so hard work. Firstly, I think, let me start off with dashboards. This is Grafana, if you're not familiar. And Grafana allows us to work with a few different backends. And here I mean observability backends. If I do this really quick, you will see a huge list of backends that you can add. It works very well with most cloud vendors. It also works very well with self-hosted stuff. So I'm using local Loki and Prometheus. And so here I'm going to zoom out here just a bit, just to show you what we're looking at. So I've crafted some very simple queries. You can stretch your imagination and see you can put more queries on top of this. But the green line in the first panel there gives you the total requests of all time. The red line gives you the total number of 5x's of all time. And that is per route. The legend below is the status code. The average request latency per route is also here. And you might not be able to see it, but that's a slash because I only have one route, and this is for the user service. So that's giving you the average latency. Below are a few gauges where it tells you the number of errors. We may want to alert on this. Like going back to what Faiz said, it's very important to have this monitoring and alerting stuff going on so that you can quickly respond to them. So this, you can imagine you have this number, you can put an alert on it and get it through Datadog, SMS, Slack, whatever it may be. And then here we have the 95th percentile of request. I think we're doing pretty good. That's 23 milliseconds. And the same thing for product service. Product service is a little higher. The reason is that kind of, to draw a mental model, the input to the system is the product service, not the user service or the auth service. So this is cumulative latency from all of the requests made to microservices. So this is metrics, and Prometheus provides a great way of tracking querying, and Grafana gives us a great way of looking at them. What I'd like to draw your attention to now is, I can't quite see this. Give me a second. I got excited with this. It's tracing. So let's just do a search, and you'll see a bunch of things here, and these are all traces. These are requests. Each one of these represent a single request to our system, and the service that is actually accepting that request. One thing that I'd like to point out before I go forward is there is a tab here. Sorry, I can't quite find it. There is a Service Explorer tab here, which actually draws out the service for you, and I'll show that to you in a second. So here, if we dive into, let's say, a request that took a really long time. This one took 77 milliseconds. That seems a little odd, and that went to product service. So let's actually go look at that. And you'll see that it opens up side by side to the UI itself. Now, this will obviously work with every other tracing backend, Jaeger, AWS X-Ray, all of that stuff. This is all locals have just kept it in tempo. This is what I mean by looking at the request flow right from when it starts. You can see that it started off at the product service. It did the DNS lookup. This is through auto instrumentation. It went to the user service. User service actually went to MongoDB. And so you have a level of granularity that is very hard to get with just logs or with just metrics. So this kind of traceability allows you to get to the point of either where you need to optimize on performance. So say, for example, there was a slow running MongoDB query. You can actually see that here. It's very visually represented. Or if there was an error, which we'll check in just a second, you can actually see where the error happened. So just looking here, I mentioned briefly at the beginning that there is something called span attributes. And these are things that you can add to the span itself to add context to what's happening. And this goes back to kind of the philosophy of observability, is that it's not just about something happened, it's about what exactly happened and where it happened. So adding context really helps. So you can see here that there's a query here. Of course, there should be PII in place and all of that stuff. You need to do that. But the ability to add this kind of stuff is supremely important. Finally, I think what I'd like to show you is, close out this panel here. Yeah, Loki is just logs, and I'll just filter by product service. This is boring old logs. I think we're all pretty used to this. There's nothing special here, but what I'd like to call out is, let me filter out not just service, but something interesting, which is the errors. So let's go really far back. Right. So we have a bunch of errors, and this is kind of orchestrated by me on purpose just to prove a point. So let's look at this error, and because of the auto instrumentation, every log line has something called a trace ID and a span ID. This goes into distributed tracing. If you actually configure things correctly a little more, you can actually have a button here that opens up tempo on the right-hand side, but I'll do that manually for now. Opening up tempo, I'll place that trace ID here, and you can see here that there was an error in the product service, and we can dive down. You can imagine you can dive down into exactly where that error happened very quickly. So there's no tailing of log lines. There's no stitching together of correlation IDs between a few different services. You just come here, you see where it happened. You think you have a hypothesis that product service has an issue. You come here, you filter, and then you debug. Therefore, it kind of helps with your debugging cycle. I was zoomed in before, but I just wanted to touch upon this service graph. I haven't been able to set this up yet for the demo, but you can imagine here that you have product service, auth service, and user service. Here you would actually see that graph, and you would see kind of requests going through, average latency between those services, etc. You would also see MongoDB in this service graph. So that's about it for my demo. I do want to touch upon, I think, the most important aspect of this, which is why you should care. Why should a DevOps person care about all of this stuff? Right. We went through this in the code. So that's just the library doing its thing. So why would DevOps care? Well, for the first thing, capacity planning. And this is actually something that comes out of a case study for me that I implemented for one of my clients. If you have all of these metrics and all of these data points coming in and you have them historically, let's say for 6 months, 1 year, you are in a better ability to say, of all of my clients who are here, I can actually kind of predict that I need X amount of CPUs, Y amount of RAM, and then provision accordingly. So for one of my clients, they had a multi-tenanted system. And multi-tenancy can mean a lot of things, but in this case, it was having separate kind of VPCs for each client or cluster of clients. And in order to correctly know how much to provision for those clients, this data came in very handy. So capacity planning is a huge win for putting in observability. Second, availability. I think this is what everybody's gunning for, especially you wonderful folks in DevOps. If you are able to detect errors or latencies early on, you're very easily able to get better MTTR and therefore reduce downtime. So if your errors are very high, if you put an alert on it, your mean time to recovery is going to be very high. If your mean time to recovery is going to be very high, your availability is going to be very high. Going forward, you can have preemptive analytics in place. So if you, even just statistically, we don't even have to do AI and ML, although that is really nice to do. You can have statistical probabilities to preemptively catch something. So if you can see that during, let's say, a flash sale of Flipkart, they had good monitoring and availability, you could say every time my Black Friday sale or whatever it's called comes over, I know for a fact I need to provision this much. So I can preemptively kind of pre-plan this infrastructure. Finally, we have anomaly detection. Given enough kind of, given enough historical data about what's happening, given enough metrics coming through your system, you can actually put in alerts in place, put in statistical AI models in place to detect anomalies. And these anomalies could be somebody trying to DDoS you, for example. It's like 12 in the morning, you typically don't have any traffic, but suddenly you have a spike in traffic, your CP is off the charts. You can have alerts in place to do that. Network issues, security issues, these all can be kind of detected fairly early on in the cycle, and you can mitigate these security threats. And so there are a bunch of other obvious use cases, I think, but I think these stood out to me as very high-level touch points of why observability really helps. So I thank you very much for taking the time to listen to me. I have some, if you have some questions, you let me know. I think we have a few minutes left. And you can scan the QR code if you'd like to connect with me on socials. Yeah.
Yeah, sure. You can have 2-3 questions, please. Not a problem. Yeah.
Yeah, go ahead.
Hey, great talk. Just wanted to understand, am I audible?
Yes.
Yeah, sure. Just wanted to understand, so hotel kind of looks like the collector part of it as a single point of failure, right? So let's say I have 20 microservices and one is busty in nature. So it will be writing a lot of metrics, logs, things. How do you make this service more resilient is the question.
Yeah, so that's actually an excellent question. That comes down to, let me quickly, this would be the architecture. Say you have 20 different microservices, and very lightly said, it's a single point of contact, a single point of failure. You can actually deploy the collector as a sidecar of the microservice itself. And therefore, you have not a central point of failure, but then each of your microservices there in this diagram would have its own hotel collector sitting along with it. This may increase CPU usage, RAM usage, but that's something that can be tweaked anyway. So that's, and the hotel collector is not very resource intensive. So if you put it as a sidecar in a pod, for example, that should potentially serve your problem. But if you can't, there are some environments where you can't put things as a sidecar for various restrictions. You can actually load balance between collectors. So various load balancing mechanisms, you can have multiple deployments of this and then load balance between them. That's a little more tricky though, because this is stateful data that's going through. You have trace IDs, which are actual stateful data of requests. So you'd have to watch out on how you do the load balancing, but you can do that.
One more last question. Anybody want to have?
So like he asked about having maybe multiple instances of hotel collector so that it is more resilient. can we put something like a queue in front of hotel collector so that even if the hotel collector is down for some time, all the messages that are cached in the queue?
Yeah, so I think the collector itself has an internal memory queue. I don't know if you can actually buffer them to an external queue.
Okay.
There's various technical reasons for that. But at a high level, I would say no. You may perhaps have to use buffering mechanisms within the hotel collector config, like I showed, to queue things up more and then send them. But your question is more to do with resilience for failure. If an hotel collector fails and has some bit of data in it, it will be dropped. You have, I think, and please correct me through the documentation, from what I remember, you can have offloading to disk, and then you can have it recover from disk and have a resumability kind of setup. But given typically telemetry data for high traffic applications, you're going to have potentially thousands a minute. So losing a few hundred records here and there over a short span of time it's not a deal breaker. But that is something to design for.
If logs are going through hotel collector, then it is a deal breaker.
Yes, it can be. So it depends on the volume of traffic that you're dealing with, and you would have to put mechanisms in place. Like I said, disk resumability is one. I think that's the only mechanism you have now. You can't offload to an external queue.
So which exact mechanism we have, like library or tech we are using for hotel collector here? Because in Signos, I saw that they have option of ingesting from Kafka.
So very quickly, oops. So you can go into GitHub's OpenTelemetry. There are two repositories to watch out for: OpenTelemetry itself and OpenTelemetry-contrib. So OpenTelemetry encapsulates, it's a Go binary. It encapsulates within it the base implementation for OpenTelemetry components. If you want things like Prometheus, AWS, Jaeger, Datadog, etc., that's in the contrib library. So if you want any of that, you have to build the library with the contrib image tag. Hotel also has a way for you to build your own. So think of them as little Lego blocks that you can put together. So you can actually build your own little hotel collector. And they provide great documentation for you to actually do that. As a side note, Cloudflare recently did that for all of its edge servers. They created a custom hotel build for each of their edge servers for specifics to their stack. So it's highly customizable. But at the base layer, it runs on Go.
Got it.
That's it, yeah.
Cool. Thanks, everyone.
Thank you so much, Vijay. Believe me, it was really impactful talk. So can I have a huge round of applause for him, please? So now I know you must be waiting for a long time. Now we will be having a short break. So right now it's 4:20. Let's come back by 4:30. The tea and coffee is there. Please, you can have a break. And yes, you can do networking as much as possible. 5, 10, 15 as you can. Please start that. Yeah. And his name is Aditya Prakash. He is a senior DevOps engineer here at GeekyAnts. He's a certified AWS developer associate with over 3+ years of experience in DevOps. And today, together, we'll be having Ansible can be leveraged to enhance your DevOps practices. So let's put your hands together for Aditya.
Hello everyone, am I audible? Yeah. So hi, I'm Aditya Prakash. I work as a senior DevOps engineer here at GeekyAnts. And today we'll be discussing how do we leverage Ansible and how do we use it to simplify our infra and configuration management. So basically today's talk does not simply focus on how Ansible works, how we write code onto it. It's rather how at GeekyAnts we have started using it and what are the different spheres we are using it at. So to begin, what was the problem statement? So when it comes to the problem statement, first of all, the major thing that we were looking at was, automating infra and configuration management. So Ansible, provided us a unified tool using which we can do both. Second thing is it simplifies scaling. How does it simplify scaling? For example, using Ansible, if we have infrastructure as code, and say for a use case, we want a pre-prod setup to go live, or maybe for a client demo, or maybe for just load testing to take place. So using the same code that we were running in staging or prod, in minutes, we can, execute that code and boot that infrastructure for pre-prod and, bring it down at runtime as and on the fly as well. Also, how has Ansible and some of our custom APIs has also helped us manage multi-cloud infrastructure? I'll be discussing that. I'm not be showing any hands-on demo. Rather, I have few recorded videos which I'll be showcasing today in today's talk. Next is reducing deployment time for familiar stacks. For example, a client comes up to us and maybe he wants us to deploy an EC2 instance with an RDS, a Redis inside a subnet along with a load balancer. And we create an Ansible code for them. So going forward, any client that comes up with a similar requirement, we don't take much time deploying their stack. We can use the same code, same templates, just a little bit tweaks here and there in the variables. We can boot up their infrastructure and manage their configurations. Last, here at GeekyAnts, we have been extensively using Ansible, and it supports all types of automations, be it, right from server audit to any manual work that we have been doing on any infrastructure or servers. We are gradually removing that and replacing that with Ansible. So what are at GeekyAnts we are using it for our client projects and also for our internal POCs and several products that we have. We are using it for infrastructure and configuration management, also for IT audit. Generating reports, running security patches, and small upgrades on the servers. As Faiz said, we have a data center of our own that we are running. So the management of those data centers and configuration management on those servers has become a lot easier using Ansible. Apart from that, and using Ansible, we have developed some custom solutions like database management and app env management, which is, we started a few days back only. It's a work in progress, but I'll try to showcase as to, give an idea around what we are doing. So just to begin, few minutes I'll take how to explain what Ansible is. So you can consider Ansible as an automation tool. In this example, you can see an Ansible instance. We feed hosts as in what servers do we want to run a configuration in, and in playbook we pass the roles, the tasks, whatever commands we want to execute on those servers or an infrastructure. We provide that to the Ansible instance. Ansible then, using the SSH protocol, executes everything onto the servers. When it comes to infrastructure, it goes ahead and deploys it onto the specific cloud provider. So basic Ansible terminologies. As I said, when it comes to configuration management, we need certain credentials like the server IP, what SSH key to be used, and what is the user using which we have to log into the server. So those information can be, that kind of information is present inside an inventory file. Next comes the roles and tasks. So you can consider, for example, let us take an example. We want to run an apt upgrade, apt update, Docker install, and an Nginx install on a particular Ubuntu server. So individual tasks like the update and upgrade task, the Docker installation task, and the Nginx installation task can be separate tasks. And this can be combined together in a role called as basic setup. And these roles are finally called using a playbook file, wherein we mention which playbook file we want to use, which roles we want to call to execute any required tasks. And lastly, what we have are handlers. So handlers are nothing but some kind of listeners. Say you want to restart a Redis service, you want to restart a MySQL service or an Nginx service. So whenever a change is made to a configuration file of any particular service, we notify the handler to go ahead and restart that service so that the new configuration is reloaded. So a basic Ansible file structure looks something like this. We have an inventory file, we have a roles in which we keep several tasks, and we have a playbook file. Everything in Ansible is plain YAML text, and it's really easy to code and get started with it. Now, how are we using Ansible for infrastructure as code? So basically, using infrastructure as code, first of all, is very beneficial whenever you are working on booting up any infrastructure, because of the fact that it is code, and when combined with tools like Git and version control, it's a very controlled environment in which we can go ahead and boot infrastructures with a number of approvals that whether the infrastructure is running or not before it goes on to production. So I can maybe this is one of the simplest architectures that one can think of: a virtual private section, a virtual private cloud in any cloud provider, a VNet that's booted, a server in the VNet in which we can access and we can access the server using SSH, a route table that connects to the VNet along with its connection to the internet gateway to provide internet to that particular virtual network. So this is one of the most basic infrastructures that we can boot on any cloud provider. So how are we handling it? So whenever a request comes to us, we simply don't go ahead and start writing vars file and booting, running playbooks and start booting the application. What we do, until and unless the cloud provider is decided, maybe if the client wants that a staging environment to run in one particular cloud provider, and then later parts of the project he wants to migrate to a better cloud provider, we generally take information in terms of generalized vars. So what we have in generalized vars are simple login credentials for that particular cloud provider. We take general information like VPC name, which region you want to boot that in, your any particular subnet CIDR you want, SSH keys, the VM name, and VM specifications like RAM, CPU, disk, and all those things. And we have created a set of infrastructure APIs in which we pass the cloud and cloud name, and it just simply goes ahead, takes the information, and creates a var file for us. So as you can see a difference in the number of vars file between AWS and AWS and DigitalOcean, because DigitalOcean will not take all the values from generalized vars, because we don't need to create route tables and internet gateway when it comes to DigitalOcean. So we have created APIs that goes ahead, separates the vars, and creates this on the fly. Next, after having created those vars, what we do is, I'll show a demo for this. The code is available. The code is visible, right? I'll show the code just a minute. I'll increase the playback speed as well. So this is my main playbook file in which I call all the roles like VPC, internet gateway, route table that gets attached to the internet gateway, a subnet, and an EC2 role. Now, as you can see, this is the vars file that was created as part of the generalized. We called we called our custom infrastructure APIs, and this was the vars files that got created. So now, as you can see, this is the vars file. Now I'll quickly show you some of the roles that we have written. The VPCs. You can see that booting up any component in using Ansible, any infrastructure is very simple. Hardly few lines of YAML content, and we can start booting up the infrastructure. So you can see we have taken values from the vars file, like the AWS VPC name. Okay. Give me a minute. It's not getting zoomed up. Is it still not visible, guys? Okay. Because are you guys not able to see the code at all? I mean, it's not getting zoomed up, so only the lower tab is getting zoomed up. I don't have the code right now. Should I continue? Hello? Am I audible? Yeah. So as I was saying that, as you can see, very few lines of code, using very few lines of YAML content, we can go ahead and boot any and every kind of infrastructure. You can see that we have certain values mentioned here in quotes and curly braces. These are the values that are taken from our vars file that we created. And whatever output, the Ansible code, when it boots up a VPC, whatever output it produces, it stores it in a VPC variable so that we can reference this VPC variable to boot other components inside of that particular VPC. So as you can see, very few lines of code we are using to boot up an internet gateway also. I'll quickly pass through the entire video. We are booting up a route table, and we are adding all the necessary records inside the route table so as to provide the subnet internet access. Later, we create a subnet and attach it to that particular route table. Going forward, you can see that we are creating on top a pair of EC2 key pairs, and we are launching an instance using all the other information that we used ahead. Now, I simply go ahead and execute my code. So whenever I'm executing my code, I'm passing the variables file that I want, and along with it, I'm passing the playbook file which contains all the roles. So now if I start executing it, here in the demo, I'll show that the components of the infrastructure start getting booted up, and I'll show the output on AWS console. So you can see when I refresh here, my VPC is booted. We are creating the EC2 key pairs, and now I'll log into AWS console EC2 dashboard, and we can see that we have a EC2 instance up and running. It's still in the initializing phase, and as soon as this comes into running state, my code execution will complete. So as you can see, we have got all the outputs. Our code has successfully executed, and we have the EC2 instance up and running. Similarly, as I showed before, we also have a set of DigitalOcean variables. So DigitalOcean, again, we'll be doing the same thing. I'll be showing you the playbook file. So the playbook file has, again, a set of all the roles that we need to call. These roles, simply go ahead and create the VPC using these particular vars, which we got as an output of our infrastructure general vars APIs. We get the VPC detail. We create a droplet and print the result of the droplet in this particular result variable. Now, when we go ahead and execute it, this will start booting infra components on DigitalOcean. So now if we go into networking, we go into VPC, we can see my VPC infra component has been booted with an IP range being picked up from the vars file. Now, if we go a bit more ahead, we can see that test droplet has started booting up. So this is how we are doing it here at GeekyAnts. We are taking generalized set of variables, and also we are gradually adding each and every infra component from each and every cloud provider, so that any and every type of infrastructure that comes to us, we are able to boot it in no time. So this has been saving us a lot of time for every client project that comes in. Next comes how we are using Ansible for configuration management and deployment. So here I'll be taking a basic example wherein I have a server ready. I'll be simply booting up a Docker container inside the server. I already have a to-do application that has been pushed to Hello World application that has been pushed to a container registry. I'll be taking in that. I will taking in login credentials for that particular ECR into my VARs file, and the certificates for my Nginx, and also the server name. So very basic information, and we have created custom roles around it that goes ahead and deploys the entire application. So if I log into the server now, I can show you that it's a pretty new server. I'll run the history command. And you can see the server is pretty new. Nothing is already running on the server. Now, this is my required playbook file wherein I call all the roles to do a Docker setup, to set up Nginx, and also roles to copy certificates and Nginx templates from my local onto that particular server. So these are some of the constants that we have been passing, like what is the part of the certificates and which path to go ahead and upload the certificates and the Nginx configuration template to. These are the Docker, these are the variables that we have been taking. For example, what domain name do you want? If you can see, the domain name here mentioned is demo.blr0.geekydev.com. And here we are taking a set of login credentials for our Docker container registry. Here we'll need an inventory file because we need to execute certain commands onto the server. We pass the IP, the root user, and the SSH port. So here I'll be showcasing some of the roles that we have written for installation of any package onto any OS. This is the bare minimum amount of lines that we need to write, and it will go ahead and install those packages. These are some custom roles which go ahead, install Docker, and set it up on the server. There are other tasks on this for custom roles that we have written for executing Docker commands onto the server. And these are some files that we are copying onto the server, which are the Nginx template files and the certificates. Now, sorry. Yeah. So now I go ahead and start executing my playbook, and you can see this is still working. Just a minute, I'll fast forward the video a bit. And when I do a Docker PS, we can see that an application on port 3000 is up and running. Now my code will go ahead and do all the required Nginx configurations onto the file, onto the server. And now the demo.blr0, which we had passed, I'll hit that URL, and you can see that the Hello World application is up and running. So any Dockerized application that comes to us, it becomes really easy for us to go ahead and deploy things on the server with some very little information on some variables, like certificates, what is the Docker credentials, and the domain name that we want. So this is how we have been managing projects for clients. I mean, this is a very basic example, guys. We have done more complex and microservices architecture as well. We have deployed Kubernetes architectures also using Ansible, both self-managed and on cloud providers, and also certain serverless architectures using ECS deploy, and using maybe Docker Swarm as well. Then comes Ansible for IT audit. So just because of the fact that we have been using Ansible, we also introduced it to the IT team, wherein whenever we have to run small security patches, upgrade servers, upgrade the OS versions onto the servers, or maybe have a server audit report at the end of every month, which we need to see is compliant to the security and or not. So we have custom Ansible code, and this is how our maybe very basic server audit report which we get, which gets the OS data, whether Linux is disabled or not, firewall is running or not, what is the SSH port, what are the various interfaces and ports and applications running on the server, what is exactly the firewall data, so as to review if we have opened any unnecessary ports or traffic to any unwanted IPs. Also, a list of users that have access to the server. So this has really helped us speed up the audit process. This particular automation has really helped us. Now, there are some custom solutions that we have developed using Ansible. Custom solutions, the few of them being database as a service and the other one being env management. So first of all, why did we start developing our custom solutions? So we had certain problems for our internal projects where we were using servers like Postgres or MySQL. If any one of you has manually gone and set up live replication or master slave architecture for MySQL or Postgres, you would have seen that it's a lot of hassle. We have to do a lot of configurations on the master server. We have to reset the master, take some data out, copy the dump to the slave folder, make some changes on the slave folder, and then the replication starts working. But the major issue comes here whenever maybe there are some poorly ran migrations, or maybe there is some network outage because of which the slave breaks. So again, we have to do the entire process. So as to avoid that manual hassle we were doing, we developed something of a database as a service. So what exactly we are doing here, I mean, it's not only for master slave architecture, it's for all the MySQL client processes, like adding, removing privileges and everything. I'll quickly show you a small demo for the database as a service which we have developed, and I'll be showcasing the master slave architecture. So I have logged into my master. You can see that MariaDB is not installed onto this. I've logged into my slave. You can see that even this is a brand new server with nothing running on it. So here we have a simple shell script which calls the Ansible code, which takes in my inventory file, my vars file, and my playbook file, and I go ahead and execute it. This is my main playbook file for my master server, wherein the first role goes ahead and installs MariaDB. The second one makes the node ready so that it can act as master. And the last one takes the information from that master, which information can be fed into my slave node. We have a similar setup for the slave node as well. These are some of the basic variable files which are mostly constants. And you can see that certain values get self-written on the fly whenever we have started, running our playbook files. So I'll quickly, go ahead in this. I'll quickly fast forward the video because again, nothing we have done. Whatever scripts that we used to run manually, we have added that to our basic Ansible YAML files, and we have started executing those. So as you can see, Ansible code has started running. It's showing me all the live logs that are happening on the server and the logs that Ansible is generating. You can see master, whatever files that the bin log position files and all those things we have got as output of Ansible, which now Ansible takes as an input for my slave node. We'll wait for the completion of this particular playbook. So now, as you can see, the pipeline, the Ansible playbook files have successfully ran, and it has returned us that both the inputs for slave IO is up and running. That shows that the master slave architecture is active right now. So now I'll log into my slave and I'll show you the live slave status for this. You can see both the yeses here. That shows that the slave is up and running. Other places where this has helped us is scaling. So whenever it comes to scaling, say adding an additional master node, or in most cases what we get the request as is addition of additional slave nodes, what we can do is we can go ahead and simply update the inventory file, and our application will go ahead and boot the entire master slave architecture. Even if a master slave architecture is up and running, we can go ahead and add slave nodes on the fly. So we have developed this for both Postgres and MySQL, and mostly for projects where bare metal database management is required. Next is something called an app env management. And why did we start doing this? Again, we started this because we had we were facing some automation issues for our, applications that were running on our bare metal servers. So for example, an application is running on our bare metal server, and we have RDS instances maybe running on AWS, a MongoDB Atlas that is booted somewhere outside. And all this booting up, we are only doing with the help of our infrastructure as code. But we wanted a singular place where we could store all the secrets. So what we found out that mostly for an application, whenever we are booting it with the help of our Ansible codes, we are getting in variables from 3 different places. The first place is the initial vars file that we pass, because whenever we boot an RDS, we pass the what database we want the name to be, what is the password that we want, all those things like the port app, what user do we want to boot up. All those things are a part of the first set of variables. The second set of variables which we get are a part of the output of the infrastructure that we get. For example, we have booted an RDS instance, we have booted a Redis instance, so we need those URLs. So that gets added. So we have created a sample template like this, and we have some third party environment variables like the Google API key, the JWT secret key, and all those things. So we have created a template like this, and what we have also created APIs which takes values from all these 3 places and creates the app env for us, which we can store in one singular place on our Ansible master node, and which can be fed to applications when they move on to deployment. So these are some of the things that we have developed using Ansible and started using it. I believe that there are still places where we have to improve, like, go ahead and improve our APIs, our templates, go ahead and add more and more roles for every other infrastructure component for any cloud provider solution. But yeah, we have started delivering this, and till now it has saved us a lot of time, and the standardization has come into picture for our team. So this is it from my end. I'm questions.
Any more questions you have?
Hey, nice talk, Aditya. You really piqued my interest with the database as a service. I'm curious, with your setup, can you, if a master goes down, is there mechanisms in place to promote a slave to master?
No, not right now.
Okay.
Because for Postgres, if we are using something of a PG pool that maintains the amount of active connections that we have, and it also does a load balancing. So if for Postgres, if we are having something of a PG pool, it has the capability to boot, push a slave back to master. But for MySQL, we don't have it right now. Yes, that is something we are developing. Yeah, because we have pitched it to our internal projects, and right now, by God's grace, everything is working fine.
Nice, thanks.
Any more questions?
Hey, hi Aditya. Nice talk. Just wanted to understand, right? So, from your point of view, there are 2 infrastructure that you manage, right? So, one is like cloud provider, maybe AWS, GCP, etc., and then there is on-prem as well, where client would come in and give you VMs to run services on. Is that kind of correct?
Yeah, that is something what we are looking at.
Sure. So, just wanted to understand from like deploying on, for example, AWS. So, if you want to, let's say, create a cluster of EC2s, you are using Ansible right now. Have you also figured out, was this thought into of using, for example, something like Terraform, right?
Yeah, actually, initially in the first phase of our data center, what we had was Open Nebula, and we had started using Terraform to boot VMs on Open Nebula. But there is a major reason why we switched to it, because we were trying to maintain 2 different tools: Terraform for infrastructure and Ansible for configuration management. So what we plan to use a unified tool, so that it helps for KT and for maintenance. If we start creating top level APIs for it, maybe an API that on the fly goes ahead and create vars file, so it will not be different for a Terraform TF vars and for the Ansible. So that is why we switched completely to Ansible for any and every kind of automation.
Got it. Another question. Let's say AWS came up with a new product, right? So let's say X. What will, so to make sure that you have code in place to basically enable X to a client, what changes will the system has to go through?
Yeah. So for Ansible, we'll have to create new roles. I mean, new set of roles. We'll have to write new code for that particular component.
Sure. So API and then YAML parsing.
Yeah, exactly. So I mean, the major thing that what we got is once we have developed an infrastructure, it becomes really easy for us to boot that similar infrastructure for any other project.
Can we have a last question if somebody have? Okay, done.
Thank you so much, guys.
Thank you, Aditya. Thank you so much for captivating session. Yeah. Thank you. So, guys, we'll be moving to the next speaker now. His name is Pavan Tikkani, and he's a founder of Prag-Matic. He has more than 17 years of experience in DevOps. And as for today, he is taking us through a journey of implement GitOps using Terraform. So let's put your hands together for him, please.
Hi, everyone. Am I audible? Good. So hi. So I'll be talking today on GitOps and how we can use leverage GitOps with some of the tools that we are familiar with. So prior to going into the discussion, I'll just give you a brief introduction about myself. So this is Pavan. I have close to 2 decades of experience in DevOps, virtualization, and cloud computing. And that span of 2 decades, I have worked for different verticals and domains such as banking, fintech, life sciences, and healthcare for companies such as Danaher, Deloitte, IBM, so forth and so on. So yeah, that's about myself. And I'm founder at Prag-Matic. So we are a tech startup into services and AI product development. So with that, I will get into the presentation bit. So today's agenda is to give you an introduction on GitOps and also the tools that are part of the GitOps ecosystem. And then we'll finally get to a demo, and all the code and the data would be shared to you through the references section. So to start with, so one of the questions that most people have is like, what is GitOps? So at the core, GitOps is like bringing the modern development practices such as DevOps and CI/CD part into the infrastructure management or the infrastructure building of infrastructure. So, and the best part about GitOps is that you don't have to adopt or get into a new set of tools. At the very basic level, GitOps works with Git repos, so which everyone is familiar with. So in case you already have a setup wherein you have you're running a CI system such as GitLab or Azure DevOps or something like that, you can just plug in GitOps into that, as we're going to see in the demo, and that's it. There is not much to it. And one of the core principles of GitOps is being declarative. So what does it mean is, in terms of GitOps, when we write infrastructure as code, we would like it to be in the form of either a language or a platform such as Terraform, wherein you write code, not code as per se, like Python or a Java, but you define this infrastructure configurations using YAML and Terraform or any of that IAC for that matter. And since it is all version controlled, so that's why it is well versioned and immutable. It has to be versioned and immutable. And another principle of GitOps is that there's something called pull-based deployments. So traditionally in software development, we are used to a push-based deployment. What I mean by that is the general workflow of your CI pipeline would be such that you will have a code repo in which you have your software development code, and then you have a CI pipeline which would be triggered based on either the developer check-in or a pull request or so forth and so on. So in that, that kind of system is known as a push-based deployment, wherein you just push in the code and then the pipeline triggers. But in GitOps, it is a bit different. So it is kind of like a pull-based deployment. So what I mean by that is, in GitOps, instead of these pipelines or this CI/CD tools, what GitOps consists of is software agents which go and sit in your infrastructure. And then they run this continuous reconciliation loops, wherein the agent will constantly check your infrastructure and the code, and it will look for any changes. If it finds any changes, it will go and implement that in your infrastructure. Now, one of the major advantages of with that kind of approach is, in terms of security, at least, and which we're going to see in the next slide, is the security aspect. So in a typical CI/CD setup or in a DevOps setup, you have to give a lot of permissions to your build agents, which are running primarily in your CI tool, such as GitLab or Azure DevOps or Jenkins. But in GitOps, you don't have to do that because these agents that run, all they need is access to the repo where you have stored your configuration files, such as the YAML definitions in Kubernetes or your Terraform code. And apart from that, you need to give it access to the repo wherein it is going to store or pull this data from. So that's it. You don't have to give it a lot of extensive set of security, I would say a lot of access controls, like a lot of access which is not required. So it keeps things very simple. And since everything is managed in a Git repo, the error recovery is also pretty fast. So you can basically, if something fails, it's as simple as you go in and do a Git revert, and then you're sorted. You don't have to get into a very separate monitoring system or anything like that. You can just use the traditional Git tools to debug what's wrong, what has happened in that space. And another thing is the GitOps also, it doesn't, it's not only limited to Kubernetes. You can basically use your traditional configuration management tools and store your, all you have to do is you have to store your code or that configuration in a Git repo, and that's all. So this talk is primarily on Flux and some of the other tools, but this can be achieved using even your traditional infrastructure configuration management tools as well. So next we are going to look into the tools side of things, which are the tools which we are going to use in today's demo. So one of the tools that we are going to use is Terraform, which I think a lot of people here would be familiar with. So Terraform, if not, Terraform is basically an infrastructure management tool, which allows you to define infrastructure configuration in a simple HCL or their own proprietary HCL language, wherein you define the infrastructure and then you store it either in Git or your local system. And then you just run the Terraform system to just plan and see what happens if the code will run. So it's kind of like a staging environment, just like in Git. So before you actually do anything, you can just do a Terraform plan and it will show you what exactly it's going to build. And then, of course, if you're satisfied with everything, then you can just go ahead and do a Terraform apply, and then it will basically provision your infrastructure. And so GitLab is one of the CI systems which is quite similar to Jenkins or Azure DevOps or any of the AWS CI/CD tools that we have in the market. But GitLab offers a lot more than just CI/CD capabilities. It also has a lot of security and compliance aspects to it, wherein you can do code scanning to find out any vulnerabilities. And apart from that, it also helps you to store your packages. It can be either a Docker container to a Java jar files or anything that you can think of. So next up is Flux. So Flux is one of the tools which is part of the GitOps ecosystem. Now, primarily, there are two main features of Flux. It follows the GitOps-based deployment, meaning Flux usually works with Kubernetes, so it goes and sits in your Kubernetes cluster and starts looking for events that require for it to trigger any changes in the infrastructure. So for example, let's say you have created a cluster with 100 pods of your application running. Now let's say you go ahead and make the changes to it and just commit to the Git repo. So what Flux will do is it will notice that change and it will reconcile and go back and make the changes automatically to the Kubernetes environment without you doing anything about it. So that leads to a very fast deployment, I would say very fast deployment rates as compared to traditional, I would say CI/CD kind of a solution. Or if you're running a typical IAC kind of a model wherein you're just triggering everything through your local system, or you're keeping it in a remote backend or something like that. And another advantage, as I was talking about the automated synchronization part, which I was just referring to, so that also plays in a key role in Flux managing these components. So there are a lot of capabilities, interesting capabilities that Flux has got. So I'm just going to go through some of them. So one is obviously the GitOps and the automation aspect. And another interesting aspect of Flux is that it also can trigger alerts. So let's say you have a communication software such as Teams or Slack. So you can integrate Flux with those kind of tools. And every time you deploy, Flux will send you a notification. So you can basically create maybe a dedicated notification channel wherein you can add the respective members who would be taking care of that. And then you can get those notifications delivered to you as Flux or any changes that are made. So in that case, in that way, you have the visibility as well. Now, one of the things is with Flux is it's an open source tool. So a lot of folks have comprehension, especially in the enterprise segment, that if it's open source, how good the support is, and what if something goes wrong. So I've been using Flux for I think almost around 4 years or so, and so far what I've seen is the community behind Flux, the developers, they're pretty good. So you get responses quite quickly for any issues that you face. So you can go ahead and test it in your environment, and you can easily implement that in the production environments as well. Now, another aspect of Flux is it's integrated with known monitoring tools such as Prometheus, Grafana, and that's where the monitoring of Flux comes in. So you can easily monitor Flux either through Prometheus and Grafana as well. So you don't have to install or configure any specific monitoring tools which only cater to Flux or something like that. So, and obviously Flux is pretty well integrated with Kubernetes. As of now, Flux can also manage Terraform resources, but more on that in a bit later. So next up, this is the overview on some of the components inside the Flux. So as you can see, there is something called controllers in Flux. So there are primarily 5 of them. Now there have been many more controllers that have come up recently, but these are the core components of Flux. The first one being the source controller. So if you remember, I was talking about the access part of the Flux, wherein you don't have to give it a lot of access. So one of the things that Flux requires is it requires access to your container registry in case if you are your image or your artifact is a container, and then it requires access to your source control. So this source controller, it keeps a tab on those repos, and it checks for any changes. The moment it detects any changes, let's say you have pushed a new code or you have pushed a new image onto your Docker container. So this is the controller that's going to take a look at it and notify other controllers. And then you have got customize, which basically helps. So once the source controller gets all the artifacts and everything, what customized controller will do is it will take those artifacts and then apply it to your Kubernetes cluster. Now, similarly, we have Helm controller, which takes care of Helm charts. And then the notification part, which I was just discussing. So the notification controller takes care of that aspect. Now, the last bit is the image reflection and automation controller. So this, there are these two set of controllers are the ones which manage these container images. So when you push something into a Docker registry like an ECR or an Azure Container Registry, so these two controllers, what they do is they will take that image tag and then they will apply it to your YAML file, which is stored in the Git repo. So this is basically this talks about the overview of all the controllers, which I was just describing. And this is a typical workflow of Flux, wherein, as we can see, whenever we push a code change into the repo, Flux will notice that change and it'll go ahead and apply to the Kubernetes. So I'll move quickly over to the demo side. So for this demo, I have recorded a video. It will not be like a live demo. So I'll just play the video and walk you through it. Okay. So to begin with, so we will be using components such as GitLab for our repo and Flux, obviously, for the management of Kubernetes resources. And apart from that, we will be building this entire setup using Terraform. So the first thing that we have to do is we have to log into GitLab and generate a PAT token, which will authenticate, which will provide the authentication or access to Flux. Sorry for that. So I'll just rewind it back. Okay. Okay. So this was the step that I was talking about, the PAT token generation. Yeah. Is this visible? You guys able to see? No? You want me to zoom in? Is this okay? Okay. So first we're going to generate the token. So one of the things that we have to do is we have to give it access to one of these. Yeah. So access to one of the repos. So that's why we are going to choose just the API from this list of access controls. That should be enough for us to, for Flux to do the changes and reconcile. And then we're going to keep the copy the token, which we're going to use it at a later stage. Next, we're going to do project creation in GitLab. Here, we're going to provide a name, and then you can choose either the project to be public or private. It depends on your preference. And then we have to select a group. So this group is something that we are going to again utilize at a later section, which I'm going to show. And that's it. So in this section, we're going to do the setup in our CLI. So the token that we copied earlier, we just have to come back and export the token. And the name of the variable, it has to be like GitLab underscore token. So this is something that is required when we do the Flux configuration for it to authenticate to the GitLab repo. So once we are done with that, also what we can do is if you don't want to like every time export it, you can just add this command to your bash RC or a ZSH file so that you don't have to export it every time. Now, what we're going to do is we're going to clone the repo which has got the Terraform files and the configuration files. Now we're going to delve into what is there in the repo. Okay, so I'll just zoom in a bit in the code so that you can see. So this is pretty standard Terraform modules. First, we are, as you can see in the code, we are trying to build a VPC and an ECR repo where we will store our container image. And here, generally speaking, as of today, the ECR in general, we used to have the scan on push, which we used to by default enable. But as of today, we can actually configure this particular setting using the ECR registry scanning configuration. So here we're just, this setting, what it does is every time you push a new image to ECR, it will scan that particular image for any vulnerability based on the database that AWS has got. And then we are basically configuring the EKS cluster. So nothing too exorbitant here. So here we are just defining some of the plugins and the add-ons which we want to install in the EKS cluster. And then there are some node groups that we are defining. So if you can see here, for the demo purposes, I have put the capacity type as spot for a EKS node group. Now this can be on demand or a mix of that. But generally speaking, spot instances are like AWS has got the reserved, not the reserved, but a spare instances, whichever AWS has got, just to save the costs when we utilize them. So those are the kind of instances which are called spot. But one thing you have to realize is if you are using this just for testing purposes, it's absolutely fine. But spot instances, though they are a great add-on to reduce your cost in the cloud, but they do get taken away from AWS with the 2 minutes of notification. So in case if you are testing it in your test environment, it's absolutely fine. But in case if you want to do it in a development environment or a little bit more advanced environments, you have to do a mix of on-demand and spot. And you obviously would need some kind of cluster autoscaler which will manage that interruptions which spot instances cause. So next here we are providing the access of the cluster to a specific principal ARN, which is basically like it can be an IAM user, or if it is a SSO, if it's an SSO setup that you've got, the SSO user role that you can put here. And then if you see the policy association, we're providing it the cluster admin and EKS admin policy, which will basically give it complete access to EKS cluster. And then here, what we are doing is So usually what I have seen is when we use Terraform to spin up EKS clusters or any Kubernetes resources, sometimes at the end of it, when the resource is configured, sometimes you get these errors where Terraform is not able to communicate with EKS cluster. So just to avoid that, we have added a local exec provisioner, which basically runs this command, which will update your local kubeconfig file with the EKS cluster that you're building. So in that way, your entire deployment goes through smoothly, and you don't have to again stop and rerun the deployment and reconfigure this. So this one step will help you in doing that. And then there are a few of these resources, such as the private key, which would be used by Flux to authenticate with GitLab. And here are some of the variables. So if you remember, I was talking about that GitLab group. When I was creating the GitLab project, I had copied the GitLab group. So that is where that value will go in here, and the project which you just created, the name of that project. So once you have that, then we'll move on to the versions. This is basically your provider configuration. So if you see here, we are having providers such as Flux, GitLab, AWS, and Kubernetes. And in the bottom, we are just configuring those provisioners with the host name, which basically would be picked up by the EKS module which we have written. Okay, so this is the application configuration. It's pretty basic Go web app, which you would be deploying to ECR. Okay, now moving on to the configuration files. So one of the challenges with ECR or repos such as that is their authentication tokens are constantly rotated. So this particular configuration file, what it will do is, it will create a cron job in your EKS cluster, which will basically do the authentication for Flux, and it will provide the token or hand over the token back to the Flux controllers. So that image automation controller which I was talking about. So it will hand over the token so that it can authenticate and pull the images from ECR and update your Flux configurations. So this is that particular file. And this is the cron job I was referring to. So usually when you spin up the cluster, immediately the Flux components are going to query those image repositories that you have configured. So that's the reason I put the schedule here as 1 minute. Usually this should be 6 hours, because the ECR tokens get expired every 12 hours. So we have ample amount of time to run this cron job. But just so that after you deploy your the Terraform bits, it should not be the case that you get errors in Kubernetes that the image is not the image controller is not able to pull the image because of the authentication issue. So that's why the schedule is kept for 1 minute. And this is the app configuration. So here, the first thing is we have defined a secret, which is basically that PAT token which we had generated in GitLab. So what you have to do is you have to basically base64 encode it. So it's pretty simple to do a base64 encoding of a string, and then put it here. And apart from that, now we'll move to this Flux components which we require for our application. So one of those is the Git repository, which I was referring to, that Flux will require access to 2 types of repositories. So this is one of them. So it is it's basically the Git repo of the files that Flux will store, the deployment.yaml files that you saw, and even the Flux configuration. So this authentication, it basically enables Flux to store that data automatically when it actually runs. And then we have this customization bit, wherein we are telling it that in this path, the /apps is where it needs to look for the Kubernetes YAML files, which it is going to go ahead and apply it to the EKS cluster. And then we have the image repository. So this is nothing but the Docker registry. So this URL is your ECR registry URL, which you're going to provide here. And if you see here, the secret reference, it's talk about the ECR credentials. So if we go back to this cron job, yeah. So this cron job basically creates that credentials every 6 hours. So that's how this is going to authenticate. So if you see here. I'll just zoom out a bit. Okay. So now what we are going to do is we're just going to, since we have cloned the repo, we're just going to run the Terraform init and the plan part. So that should spin up our infrastructure. So I'll quickly go past this. Okay. So we basically have created all the resources that we just discussed. So what happens is after this completion, the project that we had created in GitLab, what Flux will do is it will create these additional components, which is under the folder of Flux system. So there are basically three. So there are basically three components, which is sync, customization, and components.yaml. So I have linked this to in the references section. You can go through this in detail, but I'll just give you an overview of this. So this first bit, the GOTK components.yaml, it is these are all the various components that Flux. These are various GitOps components which Flux will create. So that is this file. And then the sync is basically the synchronization part, which I was talking about. So Flux has to synchronize with the Git repo. So this is that this particular file will configure that. Yeah. Okay. So I'll just walk through the application, the code part, real quick. So this is a 1 minute. Just zoom in. Okay. So this is a basic Go app, which will just run a web app at the port 8080. And this is the GitLab CI pipeline. So it basically it will authenticate with AWS ECR and then upload the image to the ECR. And these are some of the variables that you have to set for the pipeline to run. One is the region in which you are obviously going to spin up the resources, and then your AWS profile and the repo URL. And the role ARN part is something that the role that which GitLab would be using to authenticate via AWS. Okay. So now that we have spun up all the resources, now we'll just go ahead and check whether all the resources are up and running. Okay, so as you can see here, we have just run this command, which basically will list out all the pods in the Flux system. So these pods are the various components of Flux, such as Helm controller, image automation controller, and so forth and so on. Yeah. And then we are issuing this command, which basically will list all the image automation controller bits of Flux. So this is the image repository, which is there in AWS. As you can see, it was able to scan the image successfully, and it found 3 tags. Then is the image policy. So image policy, basically, it will tell Flux how to update the YAML file, and we're going to look at that. Yeah. And so this, if you get any errors here, that would mean that the authentication to the ECR is not happening properly. But since we have configured the cron job to run in a minute space, as you can see here, it already has completed. So that's why we are getting this, we are able to scan those tags. Okay, so now what we're going to do is we're going to change the application bits so that we can see what Flux will do when it detects those changes. So this is how the application looks right now. It's basically the hello world display page. So what we are trying to do here is we are trying to just change the color of that particular header. Once we do that, then the pipeline gets triggered. And this will basically create the Docker image, and then it will push to ECR. Okay. Okay, so now what we are going to do is, our application is running in the default namespace. So we're just going to watch what happens when these changes take into effect. So the -w is basically a watch command. And the moment we run it, we see that the old pod is running since 9 minutes. And now you can see that we have a new container that is coming up. So this is basically Flux detecting the change in the ECR and then making those changes in the Kubernetes cluster. And you can see here that the color has changed from blue to green. Okay, so if we go back to our repo where we had those components stored, you can see here these messages, which basically tell that, so this is authored by Flux. It basically it detected that there was a new image that was pushed, and then it added these configurations. So it actually adds this configuration in this particular file, our deployment file, where we have the image definition. I'll just zoom in into this bit so that you can see. Okay, so as you can see here, Flux has made the change to this particular definition of image, and the way it does it is through this particular snippet here. So that basically is image policy. So this first bit is the namespace name, and this is the image policy, which we had defined in one of the earlier configurations. Okay, so what you saw was basically Flux, how it manages Kubernetes components and all. But I was talking about the monitoring aspect of it, right? So we definitely can use Prometheus and Grafana, but there is one tool which is called Capacitor, which basically helps you monitor the Flux resources. So it's also an open source project. So here, so I have included these configuration files in the repo, so you can basically look at them, download and use them. So that once we apply that configuration file, this is how the application looks like. So this gives you a lot of information about what has been installed, what kind of pods are running, and you can actually see the logs of each of these components, such as the image controller, and even you can see the logs of your pod or application, which have been deployed. And you can even ask Flux to do a reconciliation through this particular portal. You can just click the button, and it'll go and check for any changes manually. And you can see the logs of the various components by just clicking on the log button. That's about it. Thank you for your time. If you have any questions?
I'm extremely sorry for that. We can just take it at the end, please, because we have really shortage of time. We can do that at the end. Or you can just put in the LinkedIn profile, and at the end we'll be getting a time for the snacks. So you can please network there. Just my request to you. Thank you. Yeah. Thank you, Pavan. Thank you so much for this. Aishman, please come for the mic. Yeah. Help, please. So guys, this is the last talk which is pending now. So let's head to the last session of this day. We have two speakers for this one. He's Aishman and Girish is just coming right away. They are the network engineers here at GeekyAnts, and they have proven experience in implementing and maintaining secure and efficient network infrastructures. They will be telling us how Zabbix can help us in monitoring. Over to you guys. So please have a big round of applause for them, please.
Hi everyone, this is Aishman, network engineer at GeekyAnts. So today we'll be explaining about like how we have set up the Zabbix for like monitoring tool for our infrastructure. Hello. Yeah, so I'll continue now. So we have used Zabbix tool as our monitoring tool here at GeekyAnts. So let's suppose if we have an organization, very small organization, they will have only 20 to 50 network components or devices or the resources which uses internet. But what if you have 500 to 10,000 servers, network components, or the services or the applications you're using into your organization? What you will do, how you will monitor that all those devices and the applications? So we come across this Zabbix tool, and now this has provided us many things. So here me and Girish both will be explaining you the half of the part, like why we have opted or selected Zabbix, what is Zabbix, and how we are configuring our network components to
be monitored using this particular tool. So this was the problem statement which I have told you right now. So this is a Zabbix tool. This is an open source monitoring tool to monitor network components, servers, applications, websites, and also the databases. Here is the content of the complete talk, what we are going to explain you. So at first, what is Zabbix? So Zabbix is an open source tool which helps you monitor network components, hardware level failures, as well as the applications. Suppose you have hosted a website, it goes down. How will you get to know that it is down? So we actually use Zabbix agent, and also it uses the agentless thing. Over there in the agentless, it uses SNMP protocol, ICMP pings to like directly ping those like network components, also the hardwares, everything, and then it collects the data. It collects data using SNMP, also using the Zabbix agent directly installed onto the network component. So why Zabbix? So we were searching for a monitoring tool. At first, we had only 50 network components in our office. So we at that time we used Uptime Robot for monitoring. If anything goes down, it actually it used to send us a message. But now when we have like scaled up our infrastructure, now we need a monitoring tool to enhance the hardware failure, like report us with the hardware failures and also with the network state if it is down or up. So here we saw like health of the hardware. Like suppose some of the hard disk is failed, it's failed. So you won't be knowing it at the same moment. So this was problem with us. So we use this software to monitor the health of hardware, state of network, all those network management network, internet network, like the public network or the private network. So it provides us comprehensive monitoring using agent and also without the agent. Also, it provides us with the live network graphs, diagrams to monitor the real-time scenarios. It has also flexible alerts. Flexible alerts, I'll tell you, you can directly point out the port-wise alerts, service alerts, and also the network interfaces if it goes down. Like, like particular alerts you can configure onto your notification systems. So here currently we are monitoring at hardware level, network level, and application level. It has features such as data gathering. It gathers data using agent and without agent. Whenever I'm saying it is without agent, it uses the protocol SNMP, Simple Network Management Protocol. For the alerting things, it has templates which has triggers to alert that to alert us with if something goes down. Then we have live network maps, which Girish will show you how live network maps looks like. Again, we have historical data storage for the previous thing, whatever happened, to analysis, like to analyze that in future if something happens, how we will be taking an action to resolve that issue. Then we have REST APIs. This APIs help us to create a new application, work with Zabbix, also to integrate Zabbix with third-party applications, and for recurring tasks. Now, network discovery. So network discovery here in Zabbix, there is a function, or you can say a feature, which actually helps us to discover each and every network component on that particular network using ICMP pings. Then here, ease of the configuration, it is in the way. Suppose you want to add a network component onto the Zabbix. So it is like you have to configure a discovery process for that particular network range, and you'll give the pool of IPs into that configuration so that it will discover all those components which are residing within that pool of IPs.
Okay, now over to you, Girish. Thank you.
Hello everyone. Myself Girish, Junior Network Engineer at GeekyAnts. So today I'll be giving a brief overview and how Zabbix plays a crucial or role in monitoring our data center environments and our network infrastructure. So these are the key components of Zabbix currently. The first thing is the Zabbix database. It is responsible for storing all the collected data from the hosts and the devices, which are the virtual machines, application servers, everything. And Zabbix also supports databases such as MySQL, PostgreSQL, Oracle, etc. And we have the Zabbix server. Zabbix server, it plays a vital role in the monitoring process because the Zabbix server is the central part of the whole Zabbix architecture system. So any data that is fetched from the servers is directly sent to the Zabbix server, and it manages the overall activity of the monitoring process. So the next one is the Zabbix agent. Suppose we don't receive any SNMP data from the host, or the IPMI protocol doesn't work. So this comes into picture where the Zabbix agent responds to the Zabbix server about all the health and status of the applications and the devices present in our data center, or suppose our office networks, any network it can be. So the next one is the Zabbix proxy. The Zabbix proxy basically acts as an intermediate between the Zabbix servers and the Zabbix agent. It reduces the offload on the Zabbix server. It takes the load, then makes it easier and reduces downtime. Next, we have the trapper. The trapper is suppose we don't want any data from the host, but when the host wanna communicate to the Zabbix server about the any breakdowns or issues, we supply a parameter to the keys in the form of trappers, and then the trapper responds to it and directly sends the data to the Zabbix server. So next we have the Zabbix APIs. We use REST APIs. In GeekyAnts, we integrated this Zabbix monitoring system with our Slack. So any triggers, any breakdowns, any issues in our data center, it directly responds to us in Slack, and we get the notification and immediately take action towards it. Next, the final part is the UI. The UI, the web interface. So this gives us a clear picture of how the servers, the connections, the data that is passed toward, and the devices which are connected to the servers, switches, routers, etc. Suppose something goes down, you can directly rectify it, seeing the interface. It has dashboards, it has maps. So this basically gives us an overview of how things can be managed easily by just visualizing by network administrators. So what are the benefits that it offers? So first thing, it is open source. So everyone, any enterprises can go towards Zabbix as an optimal solution for them. Then it is highly scalable. Large scale and small scale industries can use this and make use of it whenever they want to set up a data center and monitor their devices. Next, we have reusable templates. This is a better feature that is available in Zabbix, where the same template can be applied to multiple hosts, and it makes our jobs easier. Suppose we have multiple switches. Suppose we have a 24-bit switch and a 48-port same Cisco switch. Both are different, but the same template can be applied to both and makes our job easier to add the OS inside Zabbix. Next, we have a powerful visualization through maps. This is the live network maps. As Aishman was saying, anything that goes down, the links get triggered. Then as soon as we see the links and any downtime occurs in the connections, so we can easily rectify it. Instead of going and checking every links and monitoring every individual links, which goes down and what is up. So this provides a better visualization process. Next, we have strong reporting feature. The problems that are triggered in Zabbix have its own classifications, like there are disaster, high, not classified, and medium level problems, which are average problems. So based on these classifications, anything can be reported to the Zabbix server, and this is done by the Zabbix agent. Then we can take a necessary precaution towards it. Next, high-end community support. As it is an open source, so we are getting more support from online platforms. So this makes a better choice for us. So this is the dashboard for our data center platform, Zabbix.bold. So this is how it looks like. It has its own widgets. It is similar to the widgets that we use in our mobile phones. We can customize it to our own wish. And these are the devices that are added. Any problems that occur are triggered here. And as you can see, these problems are classified into different parts, like by severity. So not classified are those problems which doesn't need immediate action, but which can be considered. Warning is just a warning, and which can be rectified for in the future. And we have informational problems. These informational problems are like there is no need of immediate action. Suppose a disk fails and we have to replace it. So these informations are pretty necessary for it. Then we have average and average problems. They are moderate problems which might cause any issue in the future. So we can easily rectify them. Then we have the high and disaster. These cause more severity in so any issues that occur in the data center. So we can easily rectify it through this high end disaster. These may cause performance issues and operational issues and unavailability of the host. So this needs proper attention. So this is how our host looks like. These are the MNT switches, public switches, private switches, the router OS, the main router OS, through which the uplink are sent to all the racks. So this is pretty important for us. Then the chassis slots. We have blade servers, storage servers, rack servers, Cisco switches, MikroTik switches, routers, and any issue in these devices can be easily rectified once we add the host here and enable the SNMP for that. It works on port 161. Then we have the latest data for every refresh interval of 1 minute or whatever customization we set. The data will be fetched from this and will be reflected. So these are the latest data that are available. You can also see the CPU utilization. Zabbix also supports graphs. Next, coming to the maps. These are the three types of maps which are based on the data center network, where the MNT network, public network, and private network comes into action. So the public network. So I've divided it into racks. So this is the router OS I was talking about. This is responsible for sending the data to the switches. From there, it passes to the rack switches. From there, the data is transferred to all the public switches in the racks. From there to the servers. So any issue, it will be directly reflected here. The triggering will cause the change of the links to green, and so we can easily find out which links went where and what breakdown has caused this issue. Suppose we can see here. This is the informational problems I was saying. System status and critical, so it needs attention but not immediate one. This is the CPU temperature. This one has 4 problems. Suppose a link down issue has occurred, so this will be triggered. Next, we have discovery. Discovery can be done by 3 ways. It is by the IP address, by the SNMP agent, and the Zabbix agent. These 3 are responsible for discovery. Once the host is added, a similar macro is sent to the hosts and the Zabbix server. When they both verify, then the SNMP status is checked, and the host is discovered. And these are the discovered devices which comes under discovery. Next, we have services. Services are nothing but applications and databases or servers that comes up. This is the inventory data. And these are the configurations. This is host group. Suppose we want to classify our Dell products into some separate under separate manufacturer. So we can divide them and group it under a similar host. We have SNMP cards installed even for our UPS and other devices, virtual machines, hypervisors. So the reports give us the system information, how many hosts are running, how many templates are available. Everything can be monitored using Zabbix. This is mostly on the administration role. Here we can see the images that can be downloaded, and based on the devices in our infrastructure, we can add it to our network maps, and this makes our work even easier. So to identify which device is which. So this is basically about the data center. Now I'll be moving forward to our infra Zabbix, which is used to monitor all the virtual machines and the OpenStack cloud, which is available. And here you can see these are the services which we are monitoring currently. So AODH is an alarming system. Barbican has the secret keys and encryption keys on OpenStack. We have Cinder. It is basically a block storage volume allocated by OpenStack. We have pretty much important things like Keystone for API client authentication. Then we have MySQL. It acts as a primary storage system for us. Then we have Nova. Nova is basically for hosting and managing the cloud systems. We have placement to keep the track and inventory of all the cloud resources that we are using. So this gives us a clear picture of how many CPU utilization the virtual machines takes, the amount of disk storage it takes, and the free space that is available, the swap space. Everything can be monitored using this dashboard. So these are the machines available in OpenStack. LXD is basically the container which holds the OpenStack infrastructure. So everything, every virtual machine or the compute engines all come inside the LXD container. So this side menu is basically the same for all the 3 Zabbix platforms. So I'll be moving to the office network. So this is the office network. This is very useful for us, to monitor all the access points, the routers, the switches, which we use in the office network. So you can see the triggers that are available here. One of the link in cafeteria has gone down, so it is coming up here. And we've also designed the maps for the office network. So this is the west building, and this is the east building which we are standing on. One sec. Okay, this is the east building. These are the devices inside the racks which can be monitored. We can see the triggers, here, and the firewall we are using. So this is connected through a fiber channel link, which connects both the buildings from here to there. So any issue that comes up can be easily rectified by us. So as I said, these are the trigger actions available, a service discovery, internal actions that can be taken place. This is the Omada controller that we use for assigning the Wi-Fi. So pretty much this is how Zabbix helps us with its sophisticated technology to monitor every devices and make our jobs easier. And we can easily identify whether any outbreak causes in our total infrastructure. So that's it, guys. So any questions?
Hey Girish,
Yes,
nice presentation. A couple of things. Is Zabbix itself hosted on some cloud somewhere, or is it all internally hosted?
It is actually hosted on the cloud servers.
Ah, okay. My follow-up question is now moot then. What if your internal systems fail because you're monitoring of Zabbix? Do you have self-monitoring? If one of your systems go down, then do you have a way to recover your network switches and routers and all of that?
We have backups for that, sir.
Okay.
Any more questions? Yeah, that's it then. Thank you so much. Thank you so much, Aishman and Girish.
Hello.
Thank you for the demonstration. It was really nice. Thanks a lot.
Thank you, sir.
So now, guys, we are come to an end of the session here. And yes, we all thank you to all the speakers who are having a phenomenal sessions entirely. And yes, thank you each one of you who has come from far away and joined our session. And I know that today is Saturday and there must be multiple meetings overall Bangalore, but you have attended us and given us the time. We are very, very thankful to you. Can we have a clap for each one of you, please?